All right. I'm back.
Yeah. Hello. Oh, I'm sorry, everybody. We're having a little non-connecting or disconnection issues.
Oh, cool. I actually have some folks that I recognize in the chat here too.
Yeah,
See Ian.
wonderful. So, okay, Mike, why don't you come on camera and let's go ahead and introduce you. And so we'll just go right into your program.
Yeah,
So
sure.
great. So I want to welcome everybody. Thank you so much for joining today. And I really apologize for our technical issues this morning. And I'm really grateful for your patience. So today's broadcast is being brought to you by Strategic Value Plus Solutions. And we are a collective of all kinds of experts from every expert area of expertise. We bring expertise to manufacturers. And today we're going to be featuring one of our members who is going to be speaking to us about process automation. And Mike Liu is the co-founder and the president or CEO of Fuse. It's an innovative AI educational multi-platform multimedia and I can go on and on and on, but Mike is
Yeah.
an expert, and he's also a PhD, and so he's very intellectual, but also very personable. So let me just introduce him now, and he's on camera.
Yeah.
So take it away, Mike.
Awesome, awesome. And thank you for that. That was a wonderful introduction. And so I want to just make sure that I, appreciate you for that. And I'd like to say, it's one of those things where I've consistently, oh, it looks like this was shifted a weird way. So it looks like it was one of those things where I've actually forgotten sometimes that I have the doctorate because I do so many different things now that I've just been able to just get my hands into a bunch of different markets and fields. And so what I wanted to talk to you all today about, of course, is, the topic of today's conversation, obviously being about, process automation. But I wanted to kind of really sort of think about how we actually think about automation. Now, a lot of people may consider, of course, with respect to automation, there are a variety of different things that we can use out there in the marketplace. There happens to be perhaps, this thought around using Zapier, for example, or make.com. Those are, kind of some of the ideas around automating your workflows. Or perhaps you're actually thinking about how it is that you might want to figure out how to automate something in terms of, maybe an agentic workflow or AI agents, if you will, right? And so there's a lot of things that are happening right now in this space that are very, very exciting. I want to kind of take it back to first principles, though, which is, why do we actually, do an automation, right? Like, what are we really trying to accomplish? Obviously, the reduction in the time, it takes to go ahead and do something is one aspect of it. But I also think that it should, afford us the capability to be able to, kind of do something without the necessity to have to consistently think about it, right? And I think that really the idea of that goes back to habits, right? How do we habitually go and do, how do we, habitually do a thing? What are we actually doing in respect to reinforcing that habit, right? And so in order for us to actually make the most of automation, I actually want to rethink the way that we think about automation, right? And so what I want to do is kind of take us on a little bit of a journey, if you will, a history lesson slightly, and then moving into our contemporary times. And then I want to talk about how it is that we can best utilize what tools we have today in terms of software, in terms of AI, and in terms of a number of different fields. And so I'm going to go ahead and share my screen here, and let me get into my little presentation. So one second. I'm going to go ahead. I'm going to just go off cams for a quick sec just to make sure I can have this show up. So one moment, everybody. All right, perfect. So now I'm going to share my screen here. So I'm going to go and quickly move into my process automation. Now, can everybody see my screen here? Everybody can see
Yes.
my
Yep.
presentation?
Yes, Mike.
Awesome. Thank you so much. All right. It's always good to have that basis there. So, of course, I always like to kind of have a sense of, and let me go ahead and move this. Oops. Give me a second here. All right. Let me indentation here. Perfect. All right. So with regards to process automation and manufacturing, right, I always like to look at how do you actually bridge what you have in terms of, initially subtractive, of course, in terms of, those are your things like, sort of like milling, if things like the lathe. Those are obviously, different machines that you can use for subtractive manufacturing. A lot of my research actually was about additive manufacturing, really about additive manufacturing with respect to metals, right? And so what this really kind of affords us is the capability to not only be precise, but also to be, if we want to say, it allows us to be a little bit more creative in terms of how we want to implement things, right? And so the thing about a lot of those systems, though, is that they actually incorporate quite a bit of automation. There's obviously no expectation that somebody would be doing the specific processes, right? As it pertains to actually doing those automation or doing those particular operations, right? So, for example, you wouldn't necessarily be expecting somebody to go ahead and create a cast iron, something that's actually sort of cast iron in terms of metal. You wouldn't be expecting somebody to manually do that process these days. In fact, but there's obviously still plants where that is the case, but for the most part, you actually have machines, things that actually allow you to obtain a higher level precision, right? And so where I really, kind of focused on was the process automation in regard to manufacturing really is the, of course, integration of technology to really do that process control, to be able to have those minimal human output or inputs. Because at the end of the day, we're obviously not going to be, trying to input every single piece of every single part of this process, right? Even when I was using an additive manufacturing machine, particularly in my case, I was using something known as a lasered engineered net shaping device, right? For those of you familiar, it's a directed energy deposition device. For those who've actually done or have familiarity with metalworking, right? And so the idea was that of course, I'm not going to be the one utilizing the laser, right? What it actually is that you of course are putting together computer code. You are putting together it's like a design, if you will, for how the machine is going to be rastering back and forth in order to create a specific pattern, such that we would actually get the particular melt, the heat melt pools, which would happen when you wanted to have that laser essentially shooting into, basically a bunch of metals that were being posited in one section. What you would actually do is you would have essentially a pattern that you would have that be following, and so that pattern is actually what would be the specific automation. And it, of course, moves the machine around within the bounds of what is, supposed to be that particular pattern. And then because of that, we were able to judge whether something was going to be a lot more viable as a structure or not once we built it, right? So, of course, what does that afford you, right? And as you can see here, what that really provides you is things like efficiency. You're going to become much quicker in terms of the production times. You're usually going to have a reduction in your downtime. Of course, there's also precision and quality. Now, the one thing that I would actually say here, though, is a slight caveat, though, is that sometimes automations can be a little, depending on how you're doing, things like, let's say, for example, if you were looking at something that would be more of a higher step size, if you will, like basically trying to, have a laser beam that's going to actually be much more, much higher in power density, for example, you would obviously have a much larger step size with respect to something that would be much more precise, right? And there's positives and negatives to both, right? Sometimes there's obviously the idea of actually utilizing this machine to, kind of move, or utilizing that sort of setup in order to move faster in terms of the development of products and, development of what you're trying to do, right? And so, of course, with faster speeds, that obviously can come with the, other positive benefits. At the end of the day, manufacturing obviously is not just done in research labs. It's obviously done in, of course, in businesses as well. And of course, a business obviously is going to be looking at what are your cost savings, what are your optimal use of resources, right? And how does that actually affect labor costs? And so what we really, can find is that you paying attention to the particular areas of manufacturing with respect to automation can possibly, of course, allow a smaller workforce to do much more in terms of managing this, in terms of what they're responsible for, which obviously can open up into, maybe, higher efficiency, higher productiveness, and areas like that. Obviously, automations can also lead to things like increased safety, not having people do some of the more difficult and more challenging aspects, right, of a particular process was really why we started incorporating machines into this whole aspect. And then the final, couple aspects are, oops, sorry, the final couple aspects are about scalability, flexibility of process, being able to add in machines that do multiple things. You'll notice that a lot of focus right now these days is for folks to, really explore the dimensional capabilities of certain machines, right? I actually had a senior design wherein we were actually using a laser beam to not only go ahead and, measure part quality, but we were actually using it to also go ahead and make sure that there was part quality on the inside of the device that we were creating, as well as on the outside. And so automation can also come in with respect to how we're thinking about how our machines all connect together. It's actually very important. I kind of like to think about it like almost like a concerto. Everything has to be all well within the bounds of how it works. And of course, everything needs to be working in concert together so that it actually will, yield the repeatable result, right? And so that's obviously very, very important. Now, if we look at the evolution of where we're at in terms of automation and manufacturing, we really, I kind of likened it to looking at numerical controls, the early systems that you have in terms of the 1950s. And then you also have the CNC machines, right? And if anybody's, come across CNC machines, I was talking about the lathe and the mill earlier, or, some of those other machines that folks use on a regular basis. Well, the way that you can use those much more easily obviously came in the decades, post the initial numerical control mechanisms being introduced. And so that obviously allowed for the automation of complex machining. Then more, obviously in a more contemporary sense, we've started to explore into robotics. Now, robotics has allowed us to, of course, revolutionize what is automotive sense. You can, point to things like, Toyota, for example, and going back to that quality aspect, what does that really look like? Well, quality, of course, in their mind was to obviously have a different way that they did their process, right? And a different way that they took care in every step to obviously produce the highest quality, highest quality model of car. Now, obviously, in today's day and age, with things like AI and things like that, as you can see here, kind of what we, so what folks have been considering to be industry 4.0, right? The whole idea is that with, you can have smart factories, AI, IoT. In fact, there's actually a project that I'm working on with ASU, right, where they're going to actually be helping me create I forget what the word is called, kind of like a relay, if you will. And essentially, it will allow our technology to communicate with IoT devices, right? And so a lot of that actually, was born out of, kind of training purposes. But, then I realized, well, that actually could even, in fact, lead to process automation. So, in fact, what I've been able to do is really kind of sort of reinvent how it is that our platform is actually being used simply by looking at the very most important workflows and then understanding how to automate those processes as it pertains to delivering value for the end user, the person actually using the technology in this case, right? And it's funny because it kind of started off with really where they were needing to train people with respect to what it is that they were doing in these engineering use cases, engineering, technology, communication pieces as well. And so, in order to actually train people effectively, they wanted to actually have a simulated environment that would actually be a part of the training that was happening, and hence why this whole conversation came about. But it's only with the understanding of that company's workflows and understanding what it is that people were doing on a regular basis that we actually came with the idea of how it is that we could essentially or create a much more relevant and meaningful automation, and actually have something that people would use on a regular everyday basis, right? And so what I wanted to also, obviously put as a little note here is how much we've had isolated machinery actually move into systems that are what I'd like to say are, it's kind of like they're all interconnected. Of course, I kind of likened it to um, I kind of likened it to having the tendrils of all the different types of connected devices, right? You essentially have the capability now these days to even launch a workflow simply by putting a button on your phone. If anybody's familiar with the stuff that make.com does, you could actually launch a workflow simply by actually providing that workflow in a series of individual steps and activating it with your phone. So there's really this whole idea of actually having systems that are capable of being intelligent, but also, the systems that are going to be able to do things like predictive decision making, that do things like optimization, and everything of the sort. So, for we've obviously seen in regards to where we're at with core automation. Obviously, I had talked about CNC machines previously. Now, what a lot of folks may not know is how prominent, towards robotics is right now. AI robotics has been something of great interest and great, sort of intrigue for a lot of people. Obviously, we have a lot of folks who are in manufacturing realms who are, concerned that these are things that are going to be taking your job and things like that. And I've kind of been the encouragement of wanting to get folks to actually be, well versed in these systems. Similar to a program that we're actually going to be doing for anybody who happens to be in New York. Of course, we're actually going to be doing a talk the Thursday of New York Tech Week, and one of those talks is actually about getting generative AI, literacy really into the hands of students in K through 12. What's happening is we're having basically kind of like the computer lab phenomenon, right? We're having an uneven, sort of enforcement of what information should be communicated to students. And I feel like it really does, provide a disservice, because you're going to have certain students obviously be ahead of others in terms of not even just their acumen for a particular subject, but also their interest. If you're not exposed to something that often, how do you know if they're actually even going to like it? And so if we actually develop those programs, I think we're going to be leaving a lot of students behind. And so, with respect to robotics and like those types of automations, usually what that will manifest itself in is a program where the robot arm will essentially be able to operate with respect to, once again, and I'm going to keep saying the word workflow. And so that workflow obviously have that machine operate in a specific way. I had in my senior design as part of that chip manufacturing sort of check, if you will. The idea was that we would actually use the robotic arm to also pick parts up off of a conveyor belt and then be able to go and run it through the testing. The most difficult part was to actually get the specific angles that the laser would even, be able to go ahead and have a reading, and you would need to actually precisely go ahead and line up that piece to where the laser was. And these pieces were microchips, right? Like they were essentially incredibly, tiny parts that would be very difficult to even pick up, even with, a program and entire NC control about it, right? So it does lead itself, this does obviously lend itself to, the more complex automations that there are out there. Obviously, the more challenges we're going to have in terms of precision. In some of these cases, sometimes it'll be difficult to actually have a large envelope or window that we're going to be working with, and so I always kind of like to look at how is it that we can make more simple systems, because at the end of the day, a more complex system is going to be just that much more challenging to understand and more importantly to apply. So if we look at, of course, some of these other items, if anybody's not familiar, metrology is kind of the kind of the study of how we measure things. I've seen some very interesting projects that have pertained to this, right? And so that's obviously something that can be done. You can automate the process of looking at measurements and things like that. And then, of course, you can even look at things like sensors, and some of the projects that we're working on, some of the workflows are actually going to be activated by sensors and things like that. You can even look at your enterprise resource planning technology and some of those other tools, or even, maybe you actually start a workflow in manufacturing based on an order that comes in. That's a CRM, right? And so you can have like essentially all of those pieces, come together, and basically you can really see where it is that we have this interconnected set of systems for us to use. And, really a lot of things are based that way. So moving on forward to the areas that I've really studied and done a lot of research on, right? So, of course, everybody's familiar with the terminology additive manufacturing. So, of course, that's 3D printing as well, right? And so what we, of course, are able to do in our automation here is that in order to actually create a 3D printed model, we first need to design a part. Usually that's going to happen in something like SolidWorks, or some folks use other technologies as well. I kind of like to sort of conceptualize this first step as kind of being the Canva of going in and actually designing your part. But once you get that design, what do you do, right? Like, what do you do? How do you, go about actually making it? Well, what happens next is you, of course, you utilize, some printing automation. And in the case of what I did, we had multi laser systems and automated powder, management. And also we needed to be able to have an automation that would actually, shoot the, powders out at a particular, at a particular speed, at a particular, sort of density, if you will. And so it was actually sifting all of that out. And that was all just basically part of the machine. So a very complex process that even people would normally not easily be able to do is now being accomplished by a machine. And of course, that's kind of the sort of, point of how much we've actually advanced in this process, is that, things that were not obviously possible that, for human beings to do, we're now able to actually go ahead and accomplish. And so afterwards, one of the things that I, really hated as part of my post build, if you will, was the idea of how much are you going to, process, how much are you going to utilize, the robotic, the robotic depowdering was one of those areas. It would actually go and do a process where it would find defects, little powders that were still stuck to my, my builds, basically. And what would eventually happen was I needed to then say, okay, well, it would very much seem like we, are not, we don't have a really sharp final product here. I want to go ahead and utilize this depowdering. And so any of those little particles that were still stuck, we'd run it through a process, and then it would actually become a much more, clean, I guess, or much more, kind of the essentially all the rough edges were basically removed through this process. It's like the easiest way to put it. And so, some of that also will manifest itself into things like heat treatment, which sometimes that's actually located inside of some of these additive manufacturing, type of workflows and machines and things like that. And then finally, of course, what I was alluding to a moment ago was the idea of quality control, right? And so some of these systems actually accompany with it also the idea of being able to actually analyze the device or analyze the final product, being able to tell you how far you were from where your intended print was going to be. And so it will give you that feedback so that the next print that you do is actually better. Now, there still hasn't been the idea of taking in that feedback, actually putting it back into the actual operation of the device and iterating on it. I think there had been some ideas around that now with the, sort of emphasis on utilizing AI to be able to help you do so. Obviously, that would come with some level of machine learning for the machine to be able to, run that process, obviously understanding what your typical defects are going to be when you're out, when you're, of course, your final build does happen, and then you go ahead and are able to, analyze it and make sure that it's up to, up to par to what you were thinking. And so these have actually been some of the areas that folks take a lot of time to understand and look at. And as you can see here in our case study example, with respect to aviation. Companies like GE are going to utilize actually the automation here is actually for the producing of fuel nozzles, and you want to integrate robotic post-processing and real-time monitoring because as we can imagine, with a number of different areas that have had issues more recently with respect to planes and things like that. I would imagine that a lot of these folks who are going to be creating 3D printed and manufactured parts are obviously going to take the utmost care these days to obviously not have any kind of mishaps happen in the air. So moving on forward, this is actually a little bit about what I wrote with respect to directed energy deposition. My PhD professor, Dr. Matthew Kudalamadam, and myself and a few other collaborators, we actually spent a considerable amount of time really going over the ideas of what is directed energy deposition, and kind of similar to our conversation here. There was a large part around the conversation around why the system accuracy, with respect to the automation. We had parts with specific defects that couldn't be easily removed, and it couldn't even be easily solved by programming the system better, right? And so a lot of it was actually monitoring and making sure that we were not only using the systems in place that were optimal, but more importantly to see, what is really like our highest and lowest point here, right? Like what is the best that we can possibly get with respect to the particular metal, with respect to the particular combination of elements that we're putting together. My project was specifically mostly about cobalt, chromium, and molybdenum. If anybody's familiar, it's also called stellite as in terms of the alloy. And so essentially what we really had spent the time doing was I actually documented, and it's actually on archive if anybody's familiar. So ARXIV, my paper's on there. I'm also published on scholar.google.com if you ever want to check it out. Apparently they allowed it to be downloadable, so you can go ahead and see what I wrote there. But essentially what we did was we actually found common, these anomalies, right? The defects, if you will, that were going to be the most pressing and difficult for us to remove, some of the ones that were happening on a regular basis. I documented probably, I want to say like 200 pages of those, right? And what that allowed us to do was understand the quality of the machine, right? Like basically what was the capability and what was the granularity of quality that I could actually get with respect to this, machine. And we know what we found was that there was actually a need for real-time sensor integration and closed loop controls in order to actually reduce the amount of defects that were happening. Because there's like actually quite a bit at that time. Obviously, the device for the laser engineered net shaping device, or lens, if you will, it was actually a much newer device. The philosophy of not putting a bed of powder down, but instead shooting it at a single point, a single energy deposition point, which would be the laser, was really kind of like more. It was less of a known science, if you will. I think they've made some really great strides even in the last like 3 or 4 years. It's still a little bit of a ways away, but I really think it's actually the place of the future in terms of how we're going to manufacture things. In fact, what my project, my actual dissertation and what I defended while I was at Texas A&M was the idea that we were actually going to create, essentially 4-dimensional materials. What that meant was we were actually changing the composition of one of the elements, molybdenum in particular, in order to actually change we were going to basically change the properties of that material simply by changing its composition across one of the dimensions. And what we found was really funny because I actually didn't end up discovering what I wanted to discover. In fact, actually, very opposite. I found out that my initial estimates and hypotheses were not like way off, but they weren't exactly to the expectation of what I was expecting. Now, but what I did find was that actually our material was possibly usable in conditions that would be highly corrosive, and also conditions actually around the use in the human body. So we actually were developing some ideas around that, and then of course the folks who are actually in that lab still are continuing some of the work that we're doing there. So it's kind of cool to see them take the banner of what I did and run with it, right? So at the end of the day, the whole sort of process of automation was actually measured within the conversation of that paper. If and again, if you want to go and check it out, it's on archive, and it really highlighted how deep of a process understanding do you need to have in order to really move the needle, right? And I want to kind of liken it overall to the idea of where our industry is going, but why a kind of like framework to think about it, right? And how we really want to think about the whole aspect of workflows in general in order for us to completely understand how to actually automate things properly, right? And so some of the technologies that I see, in terms of this industry 4.0 and, smart manufacturing, I really think that, as I've, said, and even just kind of like the business posts that I'll put on LinkedIn and things like that, I've really kind of looked at the interconnected nature of how it is that I, have been doing business myself, but more importantly, the interconnected nature of technology in general, right? The idea that we're really defined more around intelligence, obviously, in terms of artificial intelligence, obviously, something that people really just can't stop talking about, of course, and everybody has sort of varying degrees of information and knowledge about the use of those technologies, right? But uh, then at the same time, we need to look at what are really those technologies that are really kind of going to be those ones that are going to continue moving this industry forward, right? And so one of the strategic bets that we made, and as you can see here, the very first one is IoT devices, right? And so, of course, why is an IoT device, going to be valuable in the framework that I've outlined here? Well, an IoT device obviously helps you, the IoT device, of course, is going to have continuous data collection from machines, right? Now, the second item on here, a lot of people I've come across recently haven't heard about it, which is the digital twins. Now, I'm actually working with a company, as a partner called Sigmatic.ai. And basically what Sigmatic does is that it's able, it essentially creates a virtual replica of a physical process. When in their case, they're actually modeling a physical process of being in a private practice medical facility, right? And so in their case, they're not actually using it for simulation, which is what folks that we know who are building digital twins. They're using it for training simulations. And in some of the cases, they're actually using, a connector that will connect to an IoT device in order to operate a machine. It's kind of like sort of the same ilk of what we want to do. And then, but in his case, he's really concerned about the optimization part. And if we want to talk about automating anything, the automation is that he's able to utilize a camera system within the facility of a user, so where that camera system is actually able to go ahead and not only designate whether somebody has not done something in the exact way that they obviously provided as a standard operating procedure, but they also give remediation steps. And that's actually where we come in. So the automation is that somebody happens to do something that is designated by the digital twin as being a little off base, if you will. And so our system will then go ahead and send or it'll basically send them, whether it is a text message or whether it's an email link. Essentially will that part of the process is all automated, and I've helped provide the guidance around that, but also the measurement of what are we actually sharing, in terms of that information, what makes sense in terms of when something happens and you see that X person has done something wrong. We want to remediate that particular behavior as soon as possible, right? And of course, some of that obviously is going to be done through AI and machine learning. How is it that we can look at the maintenance of things in a predictive manner? How can we be prescriptive? How do we know that we're right? How do we know that we're wrong, right? And of course, you're going to need to obviously have those models and have that framework, that gold standard. And even in the machine learning aspect of it, you can obviously get a lot of inputs around what is good, what is the gold standard, and have a number of people executing on those processes such that, by the time that you are, of course, having a larger and larger data set, you're getting closer and closer to what is, the sort of the best in class, if you will. right? And in order to do that, obviously, you need to have your complementary systems. You're talking about your cloud computing in order to be able to, handle a lot of these operations. You're going to need, obviously the scalable cloud systems. And what I wanted to particularly focus on, which is obviously, something I'd mentioned earlier, is sort of this idea of a cyber physical system, right? Now, a lot of people, if you listen to Jensen Huang from NVIDIA, or you listen to a lot of the stuff around that, there's the conversation around physical AI, right? And it's been a more prevalent concept, and it's why I've recently made strategic bets to partner with things like an AI robotics school, for example. We're going to be helping to distribute their material, right? But the actual knowledge of which I think is incredibly important. Not just for the next generation of students and the workforce, but I think it's important to codify knowledge around that, because I think it's actually going to be important for some folks who are going to want to transfer into other fields. Perhaps the work that they're doing is not as enterprising any longer, or cannot support them. Perhaps maybe even in an actual job they were doing is now requiring the necessity to understand how to use AI robotics in order for them to stay current, right? And so I think it's actually of great importance to really think through how is it that we are looking at physical AI, or in this case cyber physical systems, right? And then of course, one of the things I had actually come across, I'm working on a deal with a partner of ours for something to offer to Siemens, for example. And what we had heard about was the idea of operating the facility operating with minimal human intervention. You use AI to essentially provide real-time feedback, and essentially you get a much smarter, not just facility, but you also get a much smarter overall, set of folks who are actually working there. You reduce the amount of mistakes made. You reduce the amount of incidents with respect to, unknown, maybe like something that would be an unknown thing that wouldn't be a part of the standard operating procedure. Maybe there are some delays with respect to XYZ, right? And so we can actually utilize our data to really pinpoint what those places are, and it can run an entire automation and process control, right? So as we kind of look at some of these areas, I like to kind of do a comparison of the two different types of manufacturings, for the simple fact that I like to sort of look at the parallels, and also, of course, I like to juxtapose the differences with respect to how it is that these sort of different different philosophies, if you will, to building something are actually going to be rather similar in terms of how we automate things, right? Now, obviously, the subtractive stuff is very mature. We have a number of systems and machines and things like that, which are going to be of course, well understood. It's well understood how people do casting. It's well understood how folks do the lathe or the mill or things like that, right? The problem with those systems, and obviously in a world where we really are seeking to have much more efficiency in terms of what we do, resource efficiency, time efficiency, what have you, right, is that there's a lot of waste. There's a lot of waste in terms of both, even, right? There's a lot of waste in terms of material. There's a lot of waste in terms of time, even in some of these cases. And so, what else is there that actually is a challenge, right? Well, you're also going to have, of course, the idea of custom parts really not being that I wouldn't say feasible, but it's a much more difficult conversation to try and get custom parts, right? Now, compare those three areas with respect to the additive piece here. Additive, of course, is more along the emerging and evolving of a science. You have people spending all their time in research papers building these things up. There is minimal waste. There is you have a high flexibility, of course. You really can customize a lot more. And then there is, of course, in either case, the post processing, as I mentioned before, to make sure that parts don't have specific defects, right? Now, I do find it very interesting, though, that we have right now sort of a mindset where we have high volume, which is much more easily done with subtractive, and of course lower volumes, much more much more customized builds obviously lend itself to being part of, a more additive sort of use case, right? And where this is interesting is that I do, think that as our machines get better, as our processes get better, we actually will be able to see maybe a higher volume with respect to what it is that additive can do. I just think that we're just not there exactly yet. I think there's a lot of promising things out there in the market, but it doesn't necessarily lend itself to exactly the use case of I'm going to mass produce like 20 or 30 custom runs of something really, really complex, right? That's not really kind of the form and function of like what exists right now in your commonplace additive manufacturing, sort of setup, right? So overall, I think that there are real impacts in terms of what we're doing economically, workforce, and sustainability. But I actually want to kind of, sort of draw it back to our, what is our actual application of it? What is the importance of this specific information as it pertains to how we can actually use it, right? And I think that we can actually draw a lot of parallels and principles from learning how some of these machines actually work. And so in particular, I think that when we see how many different operations actually happen on a regular basis, we can now kind of get a sense of where do we need to begin. It can feel like an overwhelming of information or an overwhelming amount of process steps when you really break down everything that you look at in terms of how a machine or an automation works. But I'd contend, I contend that thought by saying I think that what happens is we try to make a lot more out of the very simple steps that exist, right? And we try to break them down into these really small granular areas when sometimes that's a little unnecessary. And I think that we can kind of get a best, sort of best sort of slice, if you will, if you actually look into how deep do you actually want to go in terms of learning something, right? And I kind of liken it to if you think about it, if you were to actually look at, how the human body works, right? We don't need to actually understand how it is that your kind of like body moves in order to make it move, right? And what I mean by that is, if you were to actually think about, let's say, taking a step or walking in general, right? The actual like number of different processes that would actually go into doing that is actually rather complex if you really kind of look at it, right? And so when I kind of think about, sort of this sort of aspect here, it's not that we necessarily want to even understand, even need to understand how the human body works in order to move and in order to do things, right? We just need to understand one, obviously the major, steps with regards to what you would need to do in order to do that thing successfully. And then obviously, kind of distilling it into some of the most simple parts in order to wrap our heads around it. So as it pertains to how do we capture the benefits of cost efficiency, the benefits of automating with respect to time reduction in terms of resources and things like that, rather than trying to boil the ocean and trying to think about every single process that you can do, every single thing that you can get done with automation. I think it's always just very important to start with that very first smallest step of what you can do with it, right? And if anybody uses, Zapier or Make.com, you can, probably imagine some of the more complex integrations that exist out there. Folks are actually, very good at those sorts of things. What I encourage everybody to do if you want to go and apply some of the best principles of automation is to, what I would recommend is start with something small. Start with something small and start with something where you can habitually, do it every single day. Maybe something where you create, a simple connection between two disparate pieces, right? Let's say you wanted to connect a workflow where you send your emails and you save them in a Google Drive folder, right? And let's just say, you're just connecting two things simply like that. I think in order to actually make the most out of automation, we have to build a habit around it. We have to build the idea that we think in this way. And I think the best way to do that, not the only way, but the best way to do that is to break it up into these individual, kind of parts and pieces, but then to basically connect them together on a regular basis. And I would encourage to always just try to work with the sort of smallest, most meaningful things that you can do, and then moving on from there. And so, that's really how I actually learned when I was starting to learn a lot of these software integrations and automations and things like that. That's actually been one of the more, in my opinion, has been one of the more helpful ways for me to grasp wrapping my head around what was possible in terms of automation, right? And so, what do we in and so when we look at the future, I think that if we kind of take a gander at the list of items here, I've really kind of placed my bets in terms of AI driven, autonomous, anything really. Whether you want to talk about decision making, whether you want to talk about AI agents, I think that giving some level of instruction so that a process can be run without you in the picture is going to be important business as well as important as an overall framework. And so I think that for the development of our concept and the idea around automation, we want to look at the kind of sort of evolution of it, which is going to be giving basically giving something like an AI agent some level of autonomy to go ahead and run some processes for you, which will free up your time, free up your resources, et cetera, right? A few other ones, of course, as well. There's obviously areas around sustainable automation. You want to essentially integrate these ideas into an automated workflow. Do you want to combine your additive and subtractive processes into maybe one machine? In fact, one of the machines that we had at Texas A&M was an additive and a subtractive machine, right? You had the additive part, which built it up, and then you had the CNC, the mill, and the lathe inside of the actual process flow. In fact, it was the next part of the process flow, which was really, really interesting. So overall, I want to kind of just sort of have a sense that we have a lot more at our fingertips than maybe even you were aware of before today's conversation. But I think overall, in order to harness it into the way that even makes sense, I think we have to distill it down into this, kind of the smallest ways of being able to best leverage it for ourselves in order to wrap our head around where the future can go with it. And I think if you do it in that way, you'll be able to use it in a way that's conducive to business purposes while also being very effective for yourself and hopefully reduce some time, some wasted resources, wasted energy, and that'll just give you a better life overall. So that's like basically where I feel like we have a lot of places to build on and grow. But of course, looking forward to hearing how maybe some folks build their own automations. If anybody would ever want an opportunity to chat and learn more about how I've done pretty much a bunch of my own and worked with our organization internally to basically map out all of our processes and increase our productivity by 3 to 4 times per person, I'm more than happy to talk about that on a one-on-one. But yeah, would love to just kind of like open it up to questions, and just want to say how much I appreciate everybody for sitting through my talk today.
Oh, Mike, thank you so much. You're very gracious, and we really enjoyed that presentation. Obviously, there's a lot there, and if people do want to reach out to you, just email mike@freefuse.com. But also, you can email me at our company, Strategic Value Plus Solutions. That's at strategicvalueplus.com. All right, then. So let's open this up for questions.
Yeah, well, Mike, great talk, by the way. I was very interested in what you said about the digital twin. You said you're working with a partner right now on a digital twin of a medical practice. Is that right?
Yes, actually, we are. It's actually not that I necessarily am working with him on that digital twin, but we actually are working on the workflow where the digital twin is actually going to be best utilized. So the digital twin, in our case here, is actually setting us up for the actual quality piece, in fact. So it's actually telling us what should we be doing, right? And of course, because of the sort of the best practices, if you will, that are getting measured, we're then going to be sending them a notification or something, or we're going to send them a text message in some of these cases where that will actually report that over to that individual staff member and say, hey, it would appear that you're actually doing something in a wasteful manner, and the thing is, in that industry, they're losing so much money through actually continuously doing kind of processes that are actually bleeding the facility dry to some degree. Now, obviously, I looked at the pro forma of a couple of these places, and I think that that's an exaggeration. But of course, any money where you could actually obviously save because you're doing a better process, I think is worthwhile to explore, right? And it's good to explore the using of resources. Maybe that allows you to expand. Maybe that allows you to grow your practice. Maybe that allows you to do XYZ thing. And so that's why I think it's imperative to always have this sort of reflective mentality when we think about how we do automations and how we do any type of procedure, because when you do that, it opens your mind up to different ways that you can best sort of look at how you do things on a regular basis, how your organization does things on a regular basis. And I think that that's actually going to be one of the most important aspects of how we look at our work going forward. And so that's really where I have kind of planted my stake in this, and working with a number of partners is we don't necessarily want to become an organization that obviously is just workflow oriented. We want to become an organization that can actually support the workflows that are being built on a regular basis and actually be a part of the process of improving how people do things. And so I'm very excited about what the future holds in regards to that. But it takes the first step, which is how do we best figure out a workflow that's meaningful and relevant to the people who are going to be using it on an everyday basis.
So you're basically providing the human feedback,
Yeah.
letting people know like what problems have been discovered or what issues exist, so
Yep.
that they can change their behavior so that the
Yep.
whole organization works better.
Well, the other part is you're actually developing a system of best practices, in fact, actually. So every time, you actually have the iterative, feedback, the person does that, ergo, we actually have a way that we can start measuring what is good, right? And we can say, hey, X amount of people are obviously doing things the right way. We can now actually have a gold standard with respect to that. And that can actually then continue to build out your model. You are now recording some of those best practices. You're watching as people do these things. And you can even say, hey, like this is actually not, this was actually done right. And now, what's actually happening is, we say, hey, we have a number of different ways that we're going about this particular process. We thought that this was the best way, and then inevitably what happened was we found out that like we actually had people doing it in different ways as well, and they were getting marked as being wrong, right? And so now we can actually add that to the data set and say, hey, look, these were actually misclassified. We're going to go ahead and put that back into our data set. Now we're going to be able to have a clearer picture on quality. We're going to have a clearer picture on the best ways to do something. And so now we actually not only provide the remediation and the habit building, but also we actually also will have we also will have a situation where we can really learn from how other people are doing things as well. And it might be found that maybe the process that you outlined is suboptimal for certain people. Maybe the process that you outlined is actually suboptimal for certain folks who have certain disabilities. And in fact, now you can actually make sure that you're good to go.
Yeah, that sounds fantastic. I'm looking forward to getting the video, and I have a few ideas that are just emerging just listening to you talk there. So this is fantastic stuff. Thanks so much.
Thank you, Ian. Yes, very stimulating conversation that we're having here with Mike. And let me be respectful of your time. Mike, can you take a few more questions? Do you have time?
Yeah, I absolutely, I definitely have some time, and so I'm happy to answer those questions. There's a lot of there's a lot of questions about what is possible here, and so I've tried to be as good of an aficionado as I possibly can. So feel free to ask a few more questions. I have until 12:15. So
Okay, real good. Any other questions from the floor?
Hi, Mike. My name is Brian Stitt. I do have a question. Sounded like in that example that you gave, there was some type of feedback loop that you were doing. How is that? Is the feedback loop automated, or is it something that you're documenting and just kind of sending out information as a note to everyone, or is it actually capturing it in the workflow process itself? How is that being done?
Yeah, that's actually a great question. So, I want to say it's like, there's almost like a philosophical nature to it. And I don't mean to, kind of make it as complicated as that, but some folks really do not like having everything automated, right? Like, and for whatever reason that is, that's maybe just, sort of the character or the nature of the organization. I personally am the type of person that likes to, kind of automate everything. I, more recently, and or a little bit more than I guess recently ago, I didn't really have the amount of staff that I do now, right? And so I had to get very creative about how it was that I could maximize my time, because there was a lot of opportunities that I felt like, well, I'm not capturing these. And so what ended up happening was that I found that I needed to automate more of the steps, and I needed to have more of a capability to have this thing respond without me, of course, being a part of that process. And so really what that, sort of like manifested in was actually having it automate completely. And so I've utilized tools like Airtable. Airtable's like really good with regards to actually, when you have something recorded in the table, you can actually have it, essentially watching for those specific things. I could maybe say, hey, someone, was logged in this table, for example. We saw that they were, doing something like, let's just continue using the example of the workflow that's being done at that, in that, private practice system, right? We could actually very well determine who that individual was using computer vision. We'd actually be able to see this was such and such, right? Like we could say, hey, that's Randy. Randy, seemed to have had the infraction in terms of this. We can go ahead and put, sort of log that into this, database, whether it's Airtable. You could even use a Google Sheet if you wanted to, and utilize some of the other connecting components. But basically, if somebody were logged into that sheet, in Randy's case here, we would have their information, have his information in terms of like, what department is he in, what is his phone number, what is his email address. You could send a correspondence over to the email. You could send a quick text message saying, hey, we happen to see that you were doing, something that didn't, that wasn't actually process wise what we have outlined as a part of our, standard SOP. Can you make sure that you watch this, information? It'll go ahead and send him maybe a text message with all of the video content that he needs to go and watch in order to, make sure that he's kept compliant. In this case, if you did something that was outside of the bounds of the normal SOP, they want to make sure that you actually watch that content as part of the compliance step. And then, of course, measuring whether he actually did that specific step. And then, of course, saying, hey, okay, so you actually did, watch that set of videos after to confirm that you were, doing things properly, right? And so afterwards, then we'll go ahead and send, a notice that says, hey, Brian is compliant again. He didn't do that specific, wrong operation. And so that way it's actually more, that process really would be, if you really think about it, even if you were to kind of like separate, for example, the individual pieces of it, right? So let's just say he ended up inside of that, Google Sheet or whatever, spreadsheet you have, right? And then someone would then have to pick that up and go email somebody. And then someone else may have to go in and send over the videos, right? And then someone, so what ends up happening is you have a lot of, people being introduced to the process, and it adds actually quite a layer of complexity, right? Because now you might have people who have varying things that are actually competing against the interests of making sure that this process runs properly. You have folks who are obviously not very keen on, prioritizing something like that. Then, what happens? Brian, doesn't get the right requisite, the right, sort of information in order to do this procedure correctly. He ends up doing the procedure over and over wrong. Let's say, for example, that actually leads to things like a lawsuit. And so now that process, just because it might have been spread out, he didn't associate the actual feedback with when he did that specific operation, and thus, he ended up actually jeopardizing the practice, right? And so that is, obviously, that's obviously the worst thing that could happen. And so in order to avoid things like that, I've always just found it so much more simple to actually go and have your entire workflow be accounted for. Now, as it pertains to workflows, of course, that means that you want to have the domain knowledge. It's actually why, this group, and why I think, this group actually has a lot of really wonderful folks who know so much about, various, fields within the realms of manufacturing and finance and all sorts of stuff, right? What that is really you become an arbiter of truth to, actually what it is in respect to, developing out your workflow, developing out what it is that you're doing on a regular basis. And so I think that this actually, now more than ever, it actually lends itself to why a group like this exists, right? Because a group like this exists is because, like, in the world of workflows and having all these systems talk to each other, someone needs to know how to make the map, and not enough people know how to make a map, right? Now, your decision as an org leader or somebody who's developing these workflows is: do you automate every single point of that? Do you automate? Do you break the system down into, the shorter segments and leave it as is, or do you connect all the pieces, right? So those are the areas where that's a philosophical point. Maybe you have somebody on staff who actually does all that and actually works on that for you, right? So that's fine, right? There's nothing wrong. There's nothing wrong with that, right? But make sure that there's a level of consistency, right? If you have, if you're kicking something over to one person and then kicking it over to another person, it just like causes like anarchy, right? And so I'm just of the ilk of like trying to make sure that consistency is like the largest theme, I think, in regards to that. Just if you keep things consistent, you will have a repeatable result. And at the end of the day, I think that that's really what is kind of quality to some degree, right? Repeatable results that we know we're going to be getting, an output that we know is going to be generated, right? And so that's why I think that it's important, but it's up to you, really.
Very well said.
Thank you. Yes,
Appreciate
very
it.
thorough. Any other questions? I have a question, and I really like the idea of being the arbiter of truth, because ultimately we're reliant on data, and we want to make sure that that data is reliable. So in your process, do you have, when you are setting up an automation process, is there a check, a validation of the data?
Yeah. So I kind of like to look at it as a validation on multiple fronts, right? You want to have to validate that your workflow is correct, which is you you would think it was actually easy, but once you get a bunch of subject matter experts in a room, you have a bunch of people who do things different ways, right? And so then you have to like kind of consider, okay, in what scenario is this most optimal? In what situation are we going to be doing these particular steps? In what, blah, 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 right? So what I like to kind of look at is what is the verification, if you will, of how it is that we're doing the right process, right? Because once you verify that you have the right process, then you can verify if you have the right data, right? Now, you may start with a process where you say, hey, I have data and I need to, verify what is my process, right? And in which case you might start with that data. You might say, hey, we were measuring these things. How do we actually make the most out of them? And so in order to do so, you're going to need your subject matter experts who happen to utilize that data on a regular basis, who want to actually go and create something out of that data, or perhaps in the cases of some of the work that we're doing. If anybody's familiar, I might have mentioned it to some of you before who I've met with before. There's actually a platform that I utilize right now, and our company utilizes, called Ripen. It's RIIPEN, right? And for those of you who don't know about it, it's actually a platform that provides student internships. Basically what they do is they create their capstones, their senior design projects. They actually source those through Ripen. So a company can come in and actually give a giant project actually for that, and then essentially they give that out to they give that out to the students, right? So with respect to your question, how do you know that the data that you're giving those students, how do you know it's correct, right? Now, of course, if you have a subject matter expert on your team, It's very much important to enable that person, to give them the information, easily, and give them the necessary detail in order for them to make the best decision about the quality of said things. I always try to, if we want to talk about even my own internal automations and things like that, one of the things that I've been doing is actually trying to increase the capability of communicating information in a timely manner. Knowledge transfer, I found, is actually one of the largest time sinks that we have, right? And so when we have knowledge transfer, what does that mean, right? Well, we need to communicate a process. We need to communicate data. We need to communicate information around a particular objective, right? And in order to do so effectively, we have tended to send over fireflies, right? But no one's going to read those. And then if you utilize ChatGPT, what ends up happening is you maybe don't have the clearer picture. Maybe you don't understand the context. Maybe it understood it incorrectly. Maybe it accidentally mistook a word for another word, right? And what ends up happening is you then have a mistake that gets carried over and over and over again to other people, right? And so what I wanted to actually do with respect to that was curtail that to some degree. And so right now we actually have kind of an arbiter, and I'm going to continue using that word as part of like our sort of glossary of terms here. I have an arbiter of who that meeting was in order to let us know, hey, as it pertained to this meeting, you guys talked about this. Can you please tell me, if I have this correct, right? So we allow that person to basically be the individual who can actually be the voice of truth for that specific meeting. They were the one who either ran it, they were the one who was kind of the sort of stenographer of the process, if you will. And then we actually go and, derive whether this was correct, from that particular person, right? And of course, obviously that still lends itself to, did the person even understand what was happening in the meeting as well anyway? But we've tended to, sort of elect the folks who obviously have the highest capability to understand and effectively communicate what the basis of that meeting was. And they tend to be, some of the folks that we trust are going to communicate information in an effective manner. So that's kind of how we verify data, and sort of that principle is sort of how we verify information to make sure that we're correct. And so far it's been a pretty solid system, and I can't say that I have tons of data, something we only instituted about 3 months ago, but it really was about that efficiency part of it, accuracy part of it, and most of all to just kind of meet the people of our staff where they were. It wasn't easy for folks to kind of all get on the same page. This was the way for them to do it.
Amazing. So yeah, we're 15 minutes after. We really appreciate you joining us today, Mike. I know you're a very dynamic human being. You're all over the country. Like I said, you're going to be in New York the first week in June, correct? So
Yes.
yeah, we'd love to hear more about that adventure that you'll be on, and
Yeah.
really appreciate your sharing your knowledge with us today, your insights, your perspectives, and want to learn more about tiny habits.
Yep. Yep.
As a
And
place to start.
yep, thank you. And I want to just say how much I appreciate everybody once again. For those of you who are in the New York area for New York Tech Week, please drop me a line. I want to invite you, personally to any of the events we're doing. So please let me know, and you're more than welcome.
Okay. Thank you so much, Mike.
Yeah,
Safe
thanks.
travels. Yes, you're welcome. And thank you, everybody, for joining us today. Next month, we're going to have a series of conversations around sustainability and Industry 4.0. So stay tuned yes, I hope you join us again. And we'll have another one of our members who's going to be presenting and be able to get a chance to meet Maria Perez and others. So with that, I just want to invite anyone who's on the call today to reach out to us if you have any questions about automation, digital twins, Industry 4.0, and dashboards, especially balanced scorecard type. All right, so reach us out to us at info@strategicvalueplus.com. And thank you, everyone, and have a great day.
Thank you.
Thank you.